In this video, we're going to take a look at a couple of examples of working with polynomials. So we're going to look at some adding and subtracting and multiplying with polynomials. All right, so our first example, we have the quantity 7x squared minus 3x plus 9 plus the quantity 2x squared minus 7x plus 8 minus the quantity 7x squared plus 7. And this one is just really a combining like terms problem, maybe the directions that you have seen before. The parentheses that we have around each of these three polynomials are really just to group them for this first step, and then we're going to lose the parentheses because they're not going to really do a whole lot when in this type of problem. So this first one, the parentheses aren't doing anything at all. So this is just 7x squared minus 3x plus 9. We can completely drop those parentheses there. Here we're adding our next polynomial. So again, those parentheses are not doing anything. So we can just drop those parentheses on our second polynomial. Now our last polynomial, because we have a minus here, we do need to make sure that we distribute that negative and subtract the entire quantity on this last one here. So we're going to distribute that negative to every term in this last set of parentheses. So that's going to be a negative 7x squared, and then minus positive 7 is going to be minus 7. And then our last step on this one is just combining like terms. Make sure that we get everything together. So we have a 7x squared plus a 2x squared gives us a 9x squared minus a 7x squared is going to leave us with 2x squareds. And then we have negative 3x, a negative 7x, which is going to give us a negative 10x. This last one doesn't have an x term, so we get minus 10x. And then for our remaining terms, they're all constants. We've got a plus 9 and a plus 8. That's going to give us 17 minus 7. 17 minus 7 gives us plus 10. If you want to go ahead, if your instructor is asking you to, you can factor this out. Right now we're going to leave it in this standard form here where we have our biggest power of x out front and then everything in decreasing powers of x. That's what we call standard form, and that's how we're going to leave the problems in this part. All right, our next example, we've got the quantity x plus 3 times the quantity x squared plus 6x minus 3. Now this one has a couple of different approaches. You may be familiar with a FOIL or a rainbow approach where you multiply your first term by everything in your second set of parentheses, and then you multiply your second term by everything in that second set of parentheses. And so when we do that, we're going to get x times x squared is x cubed. Remember, that's a power times a power. We're going to add our understood 1 power of x to the 2 power we have here. And then x times 6x gives us 6x squared. And x times negative 3 is negative 3x. That's what we get from our top part of our rainbow. And then on the bottom, we get 3x squared, 3 times x squared. 3 times 6x is going to be 18x, and 3 times negative 3 is going to be negative 9. And so if you have one of your parentheses here that only has 2 terms, this method works great. Just do a rainbow across the top for your first one and a rainbow across the bottom for your second one. Gets a little complicated when you have something that's like a 3 by 3. In that case, I do recommend that you use what's called the box method. So we've got, you write your first factor, x plus 3, across the top, and then your second factor going down, x squared plus 6x minus 3 going down. And then we're just going to make a box everywhere we have a different term. We're going to separate that box. And so this, when we have a binomial times a trinomial, 2 terms times 3 terms, we're going to end up with a 2 by 3 box or a 6 box. And in each of these boxes, you're going to multiply what's above it by what's next to it. And so we get x cubed. X squared times 3x is 3x squared. 6x times x is 6x squared. 6x times 3 is 18x. Negative 3 times x is negative 3x, and negative 3 times 3 is 9. Notice that it does give you the same 6 numbers that we found in the previous method, and then you can just combine like terms from either form. So our biggest power is x cubed. We've got a 6x squared and a 3x squared gives us 9x squared. Negative 3x and 18x is going to give us 15x. And then we have a minus 9. All right, when we have a perfect square, 6x minus 7 quantity squared, if we want to multiply this out, there's a couple of different ways. We can approach it the same way we did in the previous problem. We can write this as a 6x minus 7 times 6x minus 7 and do our rainbow, or do a FOIL acronym on this one will work since it's a 2 by 2, or we can do the box and do 6x minus 7 on both of them. And you will get the same answer, but if you have a binomial squared, it always follows a special pattern. If you have anything that is in the form of a plus b squared, it will always work out. You're going to square the first one, so we'll get a squared plus 2 times a times b plus square the last one, b squared. And it'll save you a little bit of work if you use that formula. So on this one, we're going to square the first. So 6 squared is 36. X squared is x squared. 2 times the first times the second. So 6x times a negative 7 is going to be a negative 42x times 2 is going to be 84x. And then squaring the last, negative 7 squared is a positive 49, which is the same thing we're going to get if we were to multiply it out and combine like terms. We just save a little bit there. And there's also a formula if we have something in the form of a plus b cubed. And this one, just like we saw in the last one, we're just going to treat this as a plus negative 7 and call that negative 7 our b. We're going to do the same thing here. If we have a binomial cubed, it always follows the pattern a cubed plus 3 a squared b plus 3 ab squared plus b cubed. Notice how our a's start out to whatever the power is in both cases, and then it decreases a cubed in the first one, a squared in the second one, a to the first in the third one, and then a to the 0. We don't have any a's on this last one. And our b's go up by 1. We don't have any b's, then we have 1 b, and then we have 2 b's, then we have 3 b's. And then our coefficient for our middle two terms is a 3. If you would like, this same formula works any binomial. You can write in the form a plus b to the n power. You can have a shortcut formula for it. You got to memorize the coefficients or figure out the coefficients that go on it. The variables will always work this way. We're going to have the first one raised to the power and then decrease the power each term and increase the power on your b each term. So here our a is x, so our first term is going to be x cubed, and then 3 times our first term squared times our second term, which is negative 3, plus 3 times our first one to the first times our second one squared, so we get negative 3 squared, plus our last term cubed. And so if we clean that up just a little bit, we're going to get x cubed. Negative 3 times 3 is going to give us a negative 9x squared for that second term. And then negative 3 squared is going to be a positive 9 times 3, which is 27x. And then negative 3 cubed is minus 27. And that is the same thing that you would get if you did your binomial x minus 3 times x minus 3 and multiply that out. You get x squared minus 2, or 2 times x times negative 3, so minus 6x plus 9 times x minus 3, and then multiply that one out like we did in the example above. It will all simplify down to this. All right, I will see you guys next time.